Welcome to another video on Smart Architectural Programming, your guide to programming fundamentals through structured, intuitive lessons. And in this video, we're moving to chapter 6 of our Introduction to Java book. And this is one of the accompanying videos to that book. And if you're watching through our channel, please learn the fundamentals of arrays as well. So we're diving into arrays in Java, which is a core foundational data structure you'll encounter in Java. And this is a very important data structure in the sense that it is the foundation of a lot of complex tasks that you might be doing in Java potentially. So that is an important understanding to take. Again, if you get, please like and subscribe our video and hit the notification bell to enjoy more of our updates on programming and Java fundamentals. So without further ado, let's push into the basics of arrays. Number one is, what is an array basically? We need to understand exactly what an array is. Let's imagine something, right? You're organizing chairs in a row for an event. And let me see if I can, draw something out here. So you're organizing chairs in a row for an event. Like, so you have, let's assume these are the chairs, right? You have arranged chairs in a row, right? Each chair has a number and a spot it takes, right? So we have, let's say, 5 chairs in a row, and each chair has a number it needs to, it needs to follow. So let me click here. We need to this, and let's change the color to cyan. So we can have 1, 2, 3, 4, and 5. So we have these values over here. 5 is a little messy, but I think it, the message come across. So each chair has a number and a spot in this position, and that's exactly how an array works. Array is a sequence of characters. Basically, an array is a container object that holds a fixed number of values of the same type, right? So just like these rows of chairs, an array could have, let's say, integers like 1, 2, 3, 4, 5 that are stored together basically, or it could have strings basically, or even objects. Arrays store multiple type of data structures in a single variable, but the caveat is that almost all of the data structures in a single array must be of the same type, right? So given that understanding, right, given that understanding that we just developed here, let's see if focus on this code over here. So you see this code here. We have an int which has square brackets, then numbers equals to new int equal 5 basically. This line declares an array of integers, right? This value here declares that we are creating an array of integers to Java. We tell Java that this variable is going to contain an array of integers, right? With space for 5 values. Now, how can we understand 5 values? This here, this is just just a structure here, but this int and square brackets, you notice there's 5 here, right? Let me see if I can change the color to red here. So this 5 here that you see here, right? This 5 in particular is the important aspect that we need to consider here, right? This 5 declares how many values are going to be in the array. It's like reserving 5 seats in advance, just like these chairs here, right? We are telling there's going to be 5 seats in a row that we're going to reserve, right? And have values stored into. That's basically what an array is. I think I've gone quite deep into this basically, but if we summarize simply what an array is, you need to understand an array is a collection of objects that are stored right next to each other in the memory, right? They need to be of the same type, data type, integer, strings. They can store anything, but one array must only contain similar types of data values, right? And then we need to reserve, and the final thing is, every array, when it's defined to an extent, we might want to reserve the number of spaces within that array as well. So that is how what an array is, and basically how you what it is in simple terms. Now that we understand that, let's move on to the next thing that we need to cover in this video, and that is declaring and initializing variables. This is an important aspect that you need to understand as well. There are 3 ways that you work with that. Let me change the color here to something green. Yeah, let's use green here. So let's focus over here, right? So we have three values here. Declaration, green seems the comments color, so let's change that to something more apparent. So we have a declaration here, a method to start an array, and an initialization method here, right? There are two main methods basically through which you can work with arrays or set up arrays, right? Declaration method is int square brackets. We're declaring array, telling that an array would be declared in this variable, which is going to be an array of ints, and then we name the array as scores, right? Another, this is the declaration step of arrays. So this is the first step that you need to do when you're setting up arrays, right? Declaring them, which tells Java what this variable is and what it would store, right? Similarly, we have initialization. Initialization here is step number 2. What happens here is that we use this, where we have told Java in step 1 that we're going to declare array of integers in the variable called scores, right? Then within that variable scores, we initialize the new array that we were talking about. Here we use the syntax of Java to declare new array, which is going to be an integer array with the value 3 here, telling us that this is going to be an array with 3 spaces or 3 adjacent values in it, right? We can do, as you can see in the previous video where I discussed that the entire process of what like in the previous slide here, and you see these different markers here, and saw how I broke down the declaration of Java here. Here you can do the same thing here at the same time, right? So these are things that you can do independently, but most people preferably for declare and initialize an array at the same time, as you can see on the screen here. So this is something that people do at the same time. They don't need to do the step 1 and then step 2. They declare and do initializations at the same time. So with that understanding, we need to also add one more thing. Let me use a razor here. I want to erase this value, right? So coming back here, you notice we have 3 values in this declaring and initialization. 90 as the let me use the razor again. So we have this value 90. I'm making the same presumption as normal mathematics. So let's change the color here again to something that we can use. Just use yellow here. Darker yellow would be better. So we have a value 90 over. It's not visible at all. Let's find another color then. Let's see. How about orange? Yeah, this might be better. Yeah. So this is going to be 0, 1, 2. We have 3 values in an array, and each of these values in the array are indexed from 0 to 1 or 2. And again, like what you need to remember, and I think I mentioned this in our previous videos as well, in programming related numbering always is 0 indexed. In programs, numbering starts from 0. 0 is 1, 1 is 2, and 2 is 3 if you want to have a comparison with general mathematics. But you need to think like that. That would just often make you more confused. Think of it this way: counting starts from 0, not 1 in programming. So basically this position here, 90, if you want to call it, its position is 0, and then 85 is 1, and 77 is 2. So that is an understanding we need to take out of this. So let's move on to the next thing, which is that we need to cover in this video, and that is accessing array elements in Java, basically. So how would you access certain values within Java, right? So we just worked on our, if you go back here, 90, 85, and 77. Those are 3 values. So let's bring them on the next page here. We have, this is too big. Let me erase this and use this color. Let's use cyan here. 90. We have 90 here. Let me go back and see what the previous were, 85 and 77. So we have 90, 85, and bear with me with my handwriting, and I think 99, 77, right? So we have 77 here. So we have three values that you can see here, 90, 85, and 77. That's the array that we declared. And we also know 90 is 0. Let me change color here again. So we mentioned the indexes. So 90 is at index 0, 85 is 1, and 77 is 2. This is because of zero indexing in programming languages, including Java. Now that you see, based on this, how do we access these individual values in the array? That is very what we're going to discuss here, and it's very simple. We use the square bracket notation to access an array value. So we have system.out.println as how we're going to print the value on the terminal. So that's unrelated to the accessing part. So you don't need to pay attention to this right now. What you need to pay attention to right now is that we declare the variable name, which is scores, and then use the square bracket notation here. And within that notation, we mention what value we want to access. And we mentioned 1. We know 85 is 1, so we pull that out. And as you'll see here, quite simply, this output that we show here is 85. So this is what how you access values within the array. Similarly, if you want to access values outside of an array range, that would not be possible. So our basically, if we talk about range, we have 3 chairs side by side in an array, right? Oh, this one got a little out of control. Let me remove that. So we have 3 chairs side by side from the chair analogy we discussed at the start of the video, right? So with these chairs have values 0, 1, 2 as their indexing, right? 0, 1, 2, right? But what would happen if we potentially want to say, hey, these are the 3 values here. These are the 3 memory spaces that we reserved for the chairs, right? But I want to sit at chair number 5. That is what this line is doing. Scores at 5. We're trying to access value at square number 5 and assigning it a value of 100. But no memory space or no chairs were reserved here. These values could be stored because a chair space was reserved for them to sit on. But when there is no chair space reserved, when we initialized or declared the array, that means we're trying to save have 5 sit in a space that wasn't reserved. And with every restaurant that you go to, if you haven't reserved a space, they're not gonna have you forcefully play come in and have someone sit at that space, right? And that is the gist of the matter. If you haven't reserved a space, if you haven't reserved a chair, that value cannot be accessed or that value cannot be stored, right? So we're trying to assign a value of 100 to chair number 5, but there's no chair number 5. There's no chair number 4 for that matter. And there's no chair number 3 as well. So what happens because of that is that we are trying to access a value that is not that the memory that has not been saved, and then we get this specific error: array index out of bound exception. Arrays in Python or any programming language for that matter are very esoteric most of the time, but it's mostly presumed that programmers can understand that. And this is the error that's thrown when you try to access a value or assign a value that is outside of the memory spaces that were reserved for the array when it was set up. Now, let's move on to the next thing that we need to understand in this particular topic, in which is looping through arrays, right? So to process all elements, loops are very handy, especially for loops and enhanced for loops in particular handling for the values in array. So we know for loops we have discussed this before. Let me delete this. This gets a little bit annoying. I can't just use Control Z, unfortunately. So as you can see, we have an array here: 0, I is less than scores.length. Scores length we know 0, 1, 2, which is 3. So length of score is 3. So let me, again, this is not the very, it's not a very intuitive system. So the value of length here is 3. Now we have that value. So we have initialized the counter at 0. So the counter can only move between 0, 1 and 2. After that, it must be less than 3, so it can't when it becomes 3, this condition becomes untrue and the loop terminates. And I++, as we've seen in the previous videos, just adds 1 after every iteration of the loop into the counter. So we're trying to print the scores value at every index point, right? We have used scores.length, so we have determined that there's a certain length of the value. So just presume, I'm not going to explain it bit by bit, that's very fundamental, but bottom line is the length variable, and if your counter starts at 0 and uses the same index here, it covers the entire length of the array and prints all the values within it. So we have values of 87, 95 and 77, something like that, and those values are going to be printed one by one in each iteration in the for loop. Similarly, if you use the for int score as an enhanced for loop here, we get the same result there as well. The first method gives us control over the indexing, while the second method is cleaner and ideal when you just need the values of the index. And this is kind of one of the features that are that are part of Java that make code very clean to use. Now that we understand that, let's move into arrays and memories. Now this is going to be something that you need to understand, very important. We need to understand that arrays are objects in Java. Java treats arrays as objects. Even primitive arrays are created in memory, and variables just hold a reference point, right? So what does that mean? So let me put it this way. We declared a variable called scores. Let's just say that's S, right? S, we told Java that S is an variable array, right? And what this means is S basically tells references to an address in the memory which has 3 boxes, right? We have 3 boxes in memory. Usually, I could explain this a little better. Let me put it this way. Let's come back to this, and let's move to this empty screen here, right? So we usually have something called RAM in every computer, right? Assume that's this chip here, right? And this chip basically holds this is the memory space of a computer, right? So let's presume that we have boxes here, and I'm just going to draw this very roughly because I just want to quickly go over this concept here. And what you need to understand from this is every box that you're seeing here is a memory space in this RAM, which basically runs the computer's memory space, right? And just presume that this is how it's working, and this is a good abstraction to visualize exactly how memory works in computer science, right? So each of this box is a memory space, and it can hold, let's say, 4 bytes of data. That's being I think that's approximately how much each box holds data point. And let's presume 4 bytes is enough to hold 1 character, 1 integer, so on and so forth, right? So when we initialize an array, it presumably, let me get a different color so I can earmark it. When we say we want to create an array with 3 memory spaces, what it happens, it finds 3 adjacent arrays and reserves them. And when we create a variable called scores, that scores holds a reference point to the address of the first memory block here. And based on that, it can go to the next one and the next one and read the entire value. So that's what it means when variable just holds a reference point. And that reference point goes to that memory, and where 3 adjacent data points store the value of the array. Understanding memory management is very essential, and I'm not going into too much detail of memory management right now because memory management helps with debugging and writing code more efficiently. And if you go to languages like C, there you even have to allocate memory, just like what I did here, but then you also have to free up memory when you want to clear that memory space, basically, because again, like with everything, you have limited resources, and computers, the limited resources is the memory that is available onto the computer itself. So this reference point is these 3 blocks somewhere in the RAM, and that's what basically variables do in context to arrays. With that, let's move on to some of the common mistakes that people make or beginners make when they work with Java, especially arrays. Number one, they forget arrays start at index 0. I repeatedly emphasized that point throughout this video. Focus on remembering that indexes start at 0. They mix up declaration and initialization. They forget about it, they mix them up, and that creates problems, because if you don't know exactly what declaration and initialization is and what it does, you're creating problems for yourself and your code. And again, they exceed array bounds. We discussed that as well. That's very common. Arrays, remember, reserved memory spaces, and those memory spaces don't expand all of a sudden when you try to go beyond it. Instead, it says, hey, no memory was reserved here. Or if you go into a restaurant without a reservation and say, I want to sit here, and try to force your way through that, you're probably going to get kicked out. That's the case here. It's going to throw a memory error and say, hey, I'm not going to do anything. You need to reserve the memory before you try to force your way in. And finally, this is a positive kind of a mistake. Rather, it's something that you need to do. The first three, what you need to avoid. The fourth one is what you need to do. Always check the length of the array using the dot length method, and that would help you avoid exceeding array bounds, because sometimes arrays are dynamic based on what input user might put in, so you might not know that exactly. So use the dot length method to get that understanding. Let's put all of that we have learned here today in practice. Try writing a Java program that stores the daily temperatures for a week and prints out the average. It's a challenge to create an array. Let's break down this channel a little bit so I can give you a little bit of context to push forward. So you need to create an array of 7 double values and calculate the weekly average temperature. Basically, that's a succinct way to do it, and it holds a little hint to that problem as well. So to recap, arrays in Java are fixed size, zero indexed collections of elements of the same time. You've learned how to declare them, initialize them, loop through them, and avoid common mistakes. In the next video, we'll explore multi-dimensional arrays and how they might open doors to working matrices and tables. If the video helped you, don't forget to like, subscribe, and hit the bell notification so that you don't miss any episodes or any knowledge that SAP puts out that would help build your career as a programmer. And also, of course, follow along with your copy of Introduction to Java for code examples, exercises, and deeper dives into the subject that we discussed here. Finally, thank you for joining us on Smart Architectural Programming. We are building better coders from the ground up.